So welcome to Dr. Hubert Lim. Hubert is Associate Professor in the Department of Biomedical Engineering and Otolaryngology at the University of Minnesota and Chief Scientific Officer for Neuromod. And Hubert's joined us today to talk about a paper that's been much anticipated by the tinnitus community, looking at bimodal neuromodulation for tinnitus and its potential impact and effects. So Hubert, maybe we can start by just asking a little bit about your background and how you got involved in this project.
Sure. And thank you, David, for having me on your, having an interview with BTA today. It's very exciting times for our company and also for the research we're doing, which I'll share, of course, more in a bit. So my background, I am associate professor at University of Minnesota, both in the biomedical engineering department, which is in the College of Science Engineering, and also in the medical school, Department of Otolaryngology. And a lot of my research during my PhD postdoc time has been in auditory prosthetics, so like cochlear implants or central implant devices. And a lot of that was trying to develop technologies to implant into the brain to restore hearing. And through that research, without going into too much detail, I stumbled upon the ability to modulate tinnitus with stimulating circuits in the brain. And it happened that non-auditory regions we unintentionally targeted that caused this modulation of tinnitus. So when I actually got to University of Minnesota, I dedicated about 50% of my lab in 2009 to pursuing tinnitus research, particularly looking at non-invasive approaches to tackle that. And so we looked at all sorts of different methods. And in my lab, we do things like electrical stimulation, magnetic transcranial magnetic stimulation and ultrasound stimulation, as well as body stimulation to try to modulate auditory circuits for tinnitus. And we combined it with sound and found some positive results in terms of stimulating the electrical stimulation of the ear, as well as the tongue. And that in turn then led Neuromod to find those results and contact me. And then that's how we kind of joined forces together, where I came over to the company side. And that's more of a brief version, but we can get into more detail of that if you're interested.
Absolutely. So, and the reason we're talking today is, of course, there's the publication now out in Science Translational Medicine that's had a lot of press interest and has been hotly anticipated by the tinnitus community as well. And the title of that paper is Bimodal Neuromodulation, Combining Sound and Tongue Stimulation Reduces Tinnitus Symptoms in a Large Randomised Clinical Study. So, maybe we start at the beginning. You mentioned a little bit in detail there about that you're looking at stimulating the tongue and the hearing, and that's really the basis of that bimodal neuromodulation, I guess.
Yeah, and so a little bit of background there, which I can go into more detail. In the auditory field, it's not just my lab. We're talking 10, 20, 30 years of research, even before I started to pursue this. Many groups, even in non-auditory field, they were stimulating two modalities or two pathways, particularly, for example, if you play pure tones, like a 1 kilohertz pure tone sinusoid, and you pair it with body stimulation, like foot or leg stimulation or another body region, they were showing that you could actually shift cells in the auditory system to become more sensitive to those cells, or you can modulate or alter the firing pattern of the cells in response to that tone. So it was already clear that you could shift coding patterns, right, neural activity of these cells in the auditory system. When I came to Minnesota, my interest was, could we push this forward for treating tinnitus and to, in a way, modulate or suppress regions in the brain that had been implicated for tinnitus. And, there were multiple groups at the time working on this. As you already know, Dr. Susan Shore at University of Michigan was looking at some combined patterns. Neuromod devices at the time was using electrical stimulation of the tongue with sound stimulation. My lab, we kind of took a unbiased approach. We took rodents and we stimulated every body region we could think of, electrical stimulation of the ear, the tongue, the neck, the body. And from that study, we found two regions that seemed to drive the strongest plasticity or changes in the auditory system that we felt were relevant for tinnitus treatment. And that was the tongue, and that was also the ear, if you applied electrical stimulation to those regions. And so we ran a few pilot studies in Minnesota that were, provided some encouraging results, but they were small scale. And for me, that was good positive results mixed in with what Dr. Susan Shore was showing, mixed in with what Neuromod had shown for their pilot studies. And so that's where I felt like we're really onto something. And that's the direction that I took to join Neuromod Devices.
Okay, and fast forwarding to the results of this trial, then it's TENT A1 trial, I think was the full name. And so, what does this study really tell us? What are the key messages out of this paper from your perspective?
Yeah, so there's three things that I am happy to share in this publication. The first thing is that, as you know, it's always difficult as an academic. We always try to run larger studies, but with our limited resources and capabilities, we're talking usually tens of participants, studies that are on a smaller scale. So what has been encouraging with this study is that we were able to enroll 326 participants. So it was a quite large study. And in that with those kinds of numbers, and the way we designed the study, we could not only look at the general cohort, but also start looking at subtyping effects and different outcome measures, and what's going on potentially with different simulation parameters. So that's one thing that is being published in this paper. The second thing is that with bimodal neuromodulation, there were many different parameters that we could explore. So we were able to kind of bundle up different sets of parameters and explore the effects of them. And we could get into that a bit later. There were some interesting things, not necessarily on the short-term scale, but on the long-term scale that came out that was quite interesting. And then the third point, I think actually to me, the most positive finding from the study is that we tracked individuals out to 12 months after they had ended treatment. And that piece, for me was something that I had not seen in the tinnitus field for a device treatment. And we were able to see that in many individuals, the treatment could last up to 12 months. That's how long we tested it. So we don't know beyond that time, but that was a key finding, that even after the treatment ended, we could drive these long-term therapeutic outcomes, which is consistent, doesn't confirm, but it's consistent with the hypothesis that bimodal stimulation is driving long-lasting changes in the brain relevant for tinnitus treatment.
And I think from our perspective as a patient organization, it's great to see a company really investing in that level of research as well, and the story continuing as well, because of course there is more research ongoing as well. So I think there's real value in really showing the effort and rigor that's gone into this research as well. So it's great to see that. But of course, patients want to know what the results are and what the outcomes are. So what can you tell us about the outcomes for patients and the outcomes for the trial participants from this?
So, the numbers we tried to systematically present in the paper, of course. Now, there's a lot of numbers and percentages, so it can get a bit confusing. So I do want to break it down a bit. When you look at, there's 326 individuals. And when you look at the total numbers, we had about, I'll say at least 2/3 that showed improvements in the tinnitus questionnaires that we use. And of course, you're familiar with them. The common ones are tinnitus handicap inventory and tinnitus functional index. So we use both of those as our primary outcome measures. So in at least about 2/3, because we did two different measures of all the individuals, we saw an improvement in scores. Now, we don't know, for the individuals who didn't come back, we had approximately about 80+% of individuals who came back for their final visit. So in those individuals, when you look at them and who were treatment compliant, so they used the device as we recommended, then we're looking at percentages, 81.2%, right, for tinnitus functional index, and then 86.2% for tinnitus handicap inventory, so THI. So then you could see in those individuals that we were actually able to assess what happened, we had quite high numbers. And then when you look at long-term effects, of course, we don't know the individuals that came back or not, but out of 151 that we were able to assess at 12 months, that is out of 326. In those 151 individuals, we were able to see 80.1% who still had a improvement in their THI or TFI score out to 12 months after treatment. So I hope that wasn't too confusing, but I wanted to provide some solid numbers there. And in the paper, sometimes it's harder to go through all the details, but that was kind of the main finding there. And I think sometimes people wonder, what those THI, TFI really mean. So we did have an exit interview, and we did ask 2 questions there. And in the exit interview, we were able to actually high number, 272 individuals, and 66.5% said they benefited from the treatment at the end. And then 270, we were able to get answers from. 77.8% said they would recommend it to another person. So that means that some of them didn't feel like they benefited, but we thought that was quite encouraging that they felt that it was doable, feasible, that they would recommend it to another person that they might potentially benefit. So those are kind of the general results.
I think it's important to make it clear as well that we're not talking about eradicating tinnitus here. We are talking about giving people benefit and improving quality of life, really, aren't we? I think, and
that's correct.
The scores are clinically significant, but we're not talking, eradication. I think I think it's always important to make these distinctions when we look at tinnitus research.
Exactly, and I will say there were just a handful that we eliminated the tinnitus, but to your point, we're basically improving their symptoms, tinnitus symptom severity, and their reactions to the tinnitus. So that's a part that we were able to assess with these questionnaires.
Okay, and the paper's a randomised control trial as well. So can you tell us a little bit about the control and how the control group responded? Because again, 12 months data on a control group is interesting in and of itself, really.
Yeah, so the way the trial was designed, we had 3 bimodal stimulation settings. And part of that, through the design was to create blinding, so they could not tell what arm they're randomized to. If you look at the paper, you can see that we pre-specified certain endpoints. And so those were within arm changes. So we're looking to see the changes within arm 1, within arm 2, within arm 3. But we also had other co-primary endpoints, which is basically we want to see between arm changes. And particularly, we want to see between arm change, arm 1, which basically had, think of sound with tongue being synchronized, happening, at the same time. And if you think about this bimodal stimulation, our view was that would potentially drive, we don't know, all of them should be therapeutic, but potentially drive longer lasting changes. And then arm 3 was, I guess in a way you could think of it as like an active control. We basically jumbled up the delay longer, and we wanted to see if we see differences between those arms. Now, what's interesting is we did see within arm significant changes. So we hit those primary endpoints, but the between arm, we did not see significant difference at the end of treatment. So what's interesting is that during treatment and within that 6 to 12 week period, all three stimulation settings that we had in that study showed significant improvements, but not much difference from each other. However, when we looked at the long-term results, we saw that arm 1 with the synchronized was pretty much a flat line sustained out till 12 months, whereas arm 3 with the delayed version was starting to approach back towards baseline about halfway up, but it still was effective long-term. It just, some of the points were not significant anymore, but still the trend was there. So I think from what I could say is that I think during the short period of time, many things can modulate the brain. So sound could potentially modulate, bimodal can modulate. I think what we're seeing from our study is that it's really this kind of long-term alteration that's happening with bimodal stimulation, which is also encouraging because when you look at Dr. Susan Shore's result from the 20 patient participant study she did, they also saw some residual effects using bimodal stimulation where they didn't see that with acoustic only. So I think this is all kind of pointing in the same direction.
Thank you. And yeah, it's really exciting to see sort of these different groups come up with similar results across, different modalities, but, the similar sort of concepts around bimodal stimulation, bimodal neuromodulation as well. So the paper's very transparent. It reports the adverse events in detail. I think a concern for people living with tinnitus will be that 64 out of the 326 participants reported tinnitus increasing through their participation in the trial. Is there anything you can tell us about that and what happened to those people?
Sure. So, obviously this is something that maybe in a follow-up we could have Dr. Brendan Conlin or Carolyn Hamilton. They're more the clinicians and the audiologists who were assessing a lot of these adverse events. I want to break it down into three points there. One is, like you said, we wanted to be fully transparent because we know that, not only the results, if you saw, we plotted every single point for each individual because we wanted everyone to know what each individual is doing. And then for the adverse events, we wanted to list everything there. As you saw, it's all listed there. So that was important. But at the same time, we did our best to classify them from probably, treatment related, possibly treatment related, and probably not treatment related. And so a lot of those, we're not, certain that our treatment was driving those changes or fluctuations. As you know, there could be some general changes. So some of those we believe was caused to that. Other cases where clearly we saw as they're using the device that it was increasing their tinnitus symptoms. Interestingly, and this is something that we'll have to validate with Caroline Hamilton, Dr. Brandon Conlon, but early in the treatment, we've noticed that multiple individuals had like an increase, but then things could subside over time for some of these individuals. And if cases, if it was bothersome, some of them did stop using the device. And these were some options. But overall, we were able to close out all of these adverse events, except for, of course, those that we had lost to follow-up. And so if there were any other concerns that we had that prolonged, we also referred them on to the appropriate people, and we listed those also in the paper. There were a few cases where we want to further investigate because we're looking into if it could cause more, bothersome situation down the road. So overall, I think considering that we did have some increase, for the most part, most of those we were able to track and resolve, and others, obviously we could hear from the participants and other people who are using the device. They can express their experiences, and I think that will help also for the community to understand what they're going through. And sorry, I said there was 3 points. And the third point is that we obviously are continuing to track with the device out in Europe now, and we're being diligent to track what are the different effects that are happening. There were some expected adverse events, and you'll see in that paper that we did have also some new adverse events, not many, just a handful, and we are also tracking those. So we try to be transparent there, which will come out in more detail in the preceding study that we have for 10A2.
Okay, and what's next? So we've already mentioned 10A2 a few times as another trial that's being running for Neuromod. So when can we expect to see those results? What does that trial protocol look like? And yeah, just a little bit more information about what the next plans are scientifically for the bimodal neuromodulation device that you're looking at.
Sure. If you in the intro, we tried to explain as best we could, kind of the design of 10A1. As you notice, we wanted to do a large-scale study, and at the same time with the large-scale study, we're limited. We can't test too many parameters because then obviously you can imagine it'd be a very huge study. So we had 3 bundled parameters. 10A2, which also, if people are interested, we have the protocol paper. Based on the results, preliminary results we have from 10A1, we were able to look at different features of stimulation, and that's pretty exciting. And that's what we're looking into in 10A2. And I hope not too long, by next year we'll be able to publish that. Of course, it takes time. We've got to go through all the data, database lock, validate, and then analyze, interpret, and then publish. And then the review process, that takes some time as well. But we do want to get that out. And for me as a scientist, after 10A2, if resources are available, I further want to find ways to create additional improvements based on identifying optimal parameters that are even more personalized for different subtypes. This is where ultimately we would like to go. Now, I will say that it's challenging because we tried our best to create these different subtypes, but still there's these were I guess you could say they were more kind of man-made subtypes, right? We said, okay, we're going to group them up into these different categories and then see if there's trends there. But we're trying to apply more kind of machine learning, big data to see if we could find more open-ended categories based on the data itself that could then potentially guide us into what treatments might be more effective for different individuals.
Sounds really exciting. I think there's a real future for that machine learning and AI in tinnitus research as well. So yeah, hope you get the funding.
Yeah, definitely.
Great. No, thank you very much, Hubert. Thank you for taking the time to talk to us today.